Jai Hind everyone. I am Professor Devendra Singh at the Department of Mechanical Engineering at Ajay Kumar Garg Engineering College. And this lecture I will take on machine design and specifically for the design against fluctuating load. As far as mechanical engineering is concerned, most of the machine elements or most of the elements are dynamic in nature. They are moving. Henceforth, if any force is acting, it will be automatically become dynamic. So most of the elements in mechanical engineering subjected to the fluctuating type of loads. So it is very essential for the mechanical engineering student to understand, to learn the design concepts against fluctuating load. So this this lecture will include the types of the fluctuating stresses, then fatigue failure and its mechanism we will discuss, then we will come to the SN curve, then we will discuss about what is endurance limit, then come to the infinite life design concepts and various criteria we use for the design purpose, Soderbergh criteria, Goodman criteria, modified Goodman criteria. So I will try these topics in this lecture. So what is dynamic load? We should understand first what is dynamic load. Dynamic load, either magnitude or direction or both vary with time, is considered as dynamic load, right? And this dynamic load will induce some stresses in the element, then those stresses are known as the fluctuating stresses. Though because stresses caused by the dynamic load or fluctuating load, so those stresses are called the fluctuating stresses. So fluctuating stresses are number of types of fluctuating stresses are there. Fluctuating or variable stresses. So I will be interested to understand three of them. First is the general fluctuating stress. Then a repeated stress. And then the reversible or I should say completely reversible stress. This is the most dangerous stress, and we will concentrate our process on this. So if I want to display these type of stresses on the load time diagram or stress time diagram, so I will draw the stress time diagram. On ordinate axis, suppose this is stress and this is time, and the stress is having some this kind of nature, right? Magnitude is changing with respect to time, then this is called the fluctuating stress. It may be this is having the change. This side positive ordinate axis, this is negative ordinate axis. So this is positive stress, this is negative stress, or positive negative stress means the direction changes positive direction or the negative direction. Here, this is in the same direction, but the magnitude is changing. What I have shown in the red color, that is fluctuating stress. In blue color, this is magnitude is changing. Here, magnitude as well as the direction changes with respect to time. That is the fluctuating stress, right? Now, another is the repeated stress. Fluctuating stress का एक special type is known as repeated stress. In case of the repeated stress, the minimum stress is always equal to 0. Maximum, then it is 0. It is repeated, then it is 0. It is repeated. This is stress. Here it is. Here on the abscissa, this is 0. This is 0. This is 0. And a set period, a definite period, time is there. This is called repeated stress. This is repeated stress. Right. And third one is reversible or completely reversible stress. If we come to this, this is stress positive. Here is stress negative. अब मैं इंट्रोड्यूस करता हूँ सिंबल. For normal stresses, we use sigma. For CI stresses, we use the tau. So, if maximum magnitude on one side, positive side, and maximum magnitude on the other side, if you see, this is a sine curve. So, another name you will find in your literature somewhere, this is sinusoidal stress, right? This is sigma max. This I will say sigma minimum, right? So, sigma max positive, the same magnitude in opposite in nature. If positive sigma I consider the tensile stresses, then the negative sigma or negative stress I will consider compressive. Same magnitude of the stress in tension and same magnitude, maximum magnitude of stress takes place in compression in the same element, then the element is subjected to completely reversible stresses or the sinusoidal type of stresses, and this is the most dangerous dangerous type of stress. Now, when we analyze all these all design concepts come into the picture, then what stress variables we use? So, we use the amplitude stress, yet these terms, amplitude stress and mean stress. In fact, these terms are self-explanatory. Amplitude, maximum displacement on one side from the mean position, that is amplitude, and the mean stress, the average which we can apply, or a stress which we can apply constant value of stress with respect to time we apply, and it will induce the same effect in the element as the real time application of these stresses produces. Then this is called the mean stress. So, we will try to understand what is this mean stress and amplitude stresses. So here I will start. This is amplitude stress, and before that we should understand the mean stress. So take an example of repeated stress. This will be easier. Maximum magnitude I will consider the same. This is repeated stress. Then the mean stress, will be somewhere in the middle. This is sigma m. This is sigma max. This is sigma minimum. So sigma m, what I will get, this difference sigma max plus sigma minimum divided by 2. By definition, this is average, right? So if sigma minimum is 0, then sigma m is equals to sigma max divided by 2. So this is sigma max divided by 2. This is the mean position, and the magnitude of on either side of this mean stress is called the amplitude stress. So this is called sigma A, amplitude stress. This is sigma A, right? So if I talk about sigma A, so mathematically I can write this is nothing but the difference between this is amplitude stress, sigma max minus sigma minimum. Here it will be sigma max by 2 in this case, right? This is the responsible stress for fatigue failure, right? And the third term, that is this sigma max minus sigma minimum, this is called the range of stress. Range of stress, or sigma r. This I have discussed for a special case of repeated stress. Now, as I have mentioned earlier, the most dangerous state of stress is the completely reversible stress, and we will find why it is so. And I hope this is very clear. What is the mean stress? Mean stress, if this magnitude of stress we apply on element, will induce the same effect. What effect has been produced by this actual repeated stress applied on the or induced in the element, that is the mean stress. Now I will take the example of completely reversible stress. This completely reversible stress, I will draw. This is maximum positive side. This is sigma max nature, positive tensile. This is sigma minimum is equals to nothing. This is negative, means compressive in nature, and magnitude is same as in the tension. This is completely reversible stress. Then find what is mean stress in completely reversible stress. Sigma max positive plus minus sigma max divided by 2, this is 0. In case of the completely reversible stress, mean stress, if you induce the 0 stress in this condition, it will induce the same effect. Sigma max minus sigma minimum divided by 2 element. So, this is completely reversible stress, repeated stress, and similarly, in general, if this is having some value, so what is maximum, sigma max, sigma minimum, these are having some value, same magnitude, we will have same formulas for sigma m, this may have some, this is sigma m, so this is sigma a. This is not sigma a, though this here we will have some vertex. This is sigma a, right? This is amplitude on positive side. Similarly, from this, if somewhere we are getting this, this is sigma a here, right? So we have discussed about the various types of the fluctuating stresses, various types of various terminologies we use. Now, we will discuss about the fatigue. The literary meaning of fatigue is if material is not capable to take further load, then we say this material is under fatigue, right? Now we come to our concern about the fatigue failure. Fatigue failure. First of all, fatigue failure is dangerous as compared to the static failure because fatigue failure takes place without any warning and it results in fracture. In fatigue failure, the element breaks in pieces and two or more pieces. Now, as far as the definition is concerned, fatigue failure may be defined. Fatigue failure may be defined as if an element is, if I should write, if a member, a member is subjected to completely reversible stress. Completely reversible stress is important in this definition. In more than 90% cases, member fails below yield point. This is also to understand, below yield point. Then the failure is called failure is called fatigue failure or member is under fatigue failure. Consider this. We will discuss further what is the mechanism of the fatigue failure. Here, yield point. So, in the last courses, whatever courses, strength of material or material science, what we have discussed, what we have learned, if this is, suppose I consider this is for mild steel only, this is fracture point, this is the yield point, and this is the true. This is knacking, so reading we will get some lower, but it in fact fails here, right? This is the yield point. So no material should fail before the yielding, right? Now, under this completely reversible stress, a very interesting example you can take. Without any chisel and hammer, you can break the wire into pieces. You just bend it in one direction with certain angle, maybe it is 45 degree, and the same angle on the other side. After few reversals, you will find this wire breaks into two pieces. Though I don't apply any load with some with chisel or hammer, or can break it in two pieces. So this is yielding yield हुआ, then it will increase, the stress level increase, and it will fail where it is unable to take or unable to offer the resistance against this applied force. Then it will fracture, it will break into two pieces. So no element can fail below its strength. So how it is? So for that, you should understand the mechanism of fatigue failure. So as far as the mechanism is concerned, the fatigue failure takes place in two steps. First is the initiation of a crack. Initiation of a crack. Then propagation of the crack. In these two steps, this fatigue failure takes place. So we will continue with the same topic, the mechanism of fatigue failure, in the next lecture. Thank you. Thank you very much.